Hello everyone. In this lesson we're going to take a look at using Newton's second law to solve a problem for a system of objects. And that means we're going to look at the whole system rather than the individual objects. We looked at the individual objects in lab and now we're going to apply that to a system. So I'm going to do two problems. Our first problem, we're going to have a pulley and we have a bucket over here and a bucket over here, and these buckets have mass. I'm going to call this one M1 and this one M2. And let's say that M1 is equal to 10 kilograms and M2 is equal to 5 kilograms. Okay? And these are held at rest and then released, and what we want to do, I want two things. I want to find the acceleration and I want to find the tension. Okay? Now, whenever we do a problem like this, we should start with drawing our forces, labeling our forces, but we should also understand what the pulley does. The pulley is a direction changer, and so I like to assign a positive direction, and I'm going to go ahead and let my positive direction be this way. Okay? That means up is positive on the right side of the pulley, and down is positive on the left side of the pulley, and that pulley is just rotating my positive direction for me, because this rope loops over that pulley, and so it changes the direction of the force. Now, I do want to go ahead and label the forces that are acting. So on M2 I have F2G, and on M1 I have F1G. Now, those are the only external forces to my system. And by external forces, I mean forces that come from outside of the system. Since my system consists of this mass and the rope that holds them together, the forces in the rope are actually part of the system. So yes, that tension force is there, but I'm going to ignore it for now because I'm going to find the acceleration of the system. And once I have the acceleration of the system, finding the tension is actually fairly easy. So my system has two forces acting on it, so I'm going to apply Newton's second law to that. Net force equals mass times acceleration, and so net force means sum of the forces. Well, over here I have positive F1, it's going down, and over here I have negative F2, and it's negative because it's going down, but it's going down on the wrong side, right? So over here up is positive, and over here down is positive, and I've got to do that because my pulley's making a change in direction. So I'm going to go ahead and say F1G plus F2G equals MA. Now be careful here, we want to know what that M is. Well, F1G is the force due to gravity acting on mass 1. So this is M1 times G. F2G is the force due to gravity acting on mass 2, but on this side G is negative, so I'm going to go ahead and put that in. And then this equals M. But M is not M1 or M2, it's the mass of everything that's being accelerated, and everything that's being accelerated is M1 plus M2, so M1 plus M2A. Now the only unknown I have in this whole giant equation is A, right? So I can start subbing stuff in. I'm not going to yet. I have M1 minus M2G. So I'm going to go ahead and pull out that G. I'm going to go G times M1 minus M2 equals M1 plus M2A. And now I can divide both sides by M1 plus M2. And so I get G, 9.8, times M1 minus M2. Well, M1 is 10, M2 is 5, divided by 10 plus 5. And so I've got 5 times 9.8 divided by 15, or 49 divided by 15, which equals 3.4-ish. Okay? And of course that is meters per second per second. That is the acceleration of the system. Now, I asked for the acceleration of the system, but I also asked for the tension in the string. Well, if I want the tension, that means I have to focus only on one object. And I have to focus on one object because now I can look at this part of it and I can say, well, there's tension acting here and there's gravity acting there. So if I focus only on object 2, I could have picked object 1, it doesn't matter, then I'm going to get the tension force. So I'm going to say, all right, the net force acting on object 2 over here, and I have positive is up, is equal to Ft plus F2g, and now the mass that's being accelerated is just the mass of object 2. So I have Ft, which I don't know. F2g is plus, M2 is 5, g is negative 9.8 right there because it is down and down is negative, equals 5 times a, but I know a, it's my 3.4 that I calculated there. And so now I have Ft is equal to, and I'm going to have to add this over, so 5 times negative 9.8 is negative 49, but I'm going to add that to both sides, so I have 49 plus 5 times 4 is 17.0, and that gets me a total force of tension of 66 newtons. Okay? Now let's stop and think about that number. Does it make sense that my tension force is 66 newtons? Well, this force is 49 newtons, and so if this force is 66 newtons, that means that yes, this part should accelerate up. This force, 10 times 9.8 is 98 newtons, and this force, this would also be 66 newtons, it's the other side of that rope. That means this thing should accelerate down, and that's the way everything is going. So it does make sense that my tension force is between my two gravitational forces. Now we could double check ourselves and we could look at this object and we could say, well, the net force acting on object 1 is equal to 98 minus 66, and that should equal M1, 10, times A, and this A should be the same as this A, give or take whatever rounding errors I have, so 32 equals 10A, and divide both sides by 10, and I do see I get an acceleration of 3.2, and that is essentially my 3.4. I just rounded and estimated my math here. So we do see that our acceleration agrees on both sides, our force makes sense for both things, so we applied Newton's second law to get the acceleration of the system, and then we applied Newton's second law to an object to get the tension force acting on the object.